Hello students, let us say we have a marker here and we want to measure the length of this marker with a scale, with a ruler. Can we measure it to 100% accuracy? It's not possible. No matter how precise the instrument is, how wonderful our eyesight is, still there is some uncertainty. Of course, if the instrument is very precise and our eyesight is wonderful, the uncertainty may be less, or if the precision is less, the uncertainty may be more. But there is an uncertainty in the measurement of any value. So, that uncertainty in physics is called an error in measurement. Today, we'll understand these errors in more detail. Uncertainty in measurement is called error. Before we go deeper into errors, let us understand these two clearly. What is precision, what is accuracy, and what is the difference between them? Precision. Precision is to how close a value you can make a measurement. Let us say the length of a rod is 3.8 centimeters. And we have used an instrument and we said it's 3.8. Suppose somebody uses a better instrument and he says it is 3.845. Now there are more decimals, meaning very closer and closer to a smaller value they are able to measure that. So this is more precise. More decimal, more precise. Means they are able to measure to closer and closer values. What is accuracy? Accuracy is how close we are to the true value, to the actual value that we are measuring. So let us say the actual length of this is 3.7 centimeters, and let us say somebody is measuring it to 3.6. One measurement is 3.6 and another measurement is 3.3. Now this is very close to the true value, the actual value, whereas this is very far away. So this is less, this is more accurate, and this is less accurate. So accuracy is how close we are to the true value. Now, what do you mean by true value? When there is, when we already measured that there is an uncertainty in measurement. So what is a true value? When we don't know the exact value, we take the average of some measurements and that average becomes the actual value or true value. So how close our measurements are to the actual value is accuracy, and how many to what smaller value we can measure is precise. Let us take an illustration here which will help us understand the difference between precision and accuracy. Let us say we have a dartboard and we are throwing darts. Now look at this. The darts are very close to each other. The distance is not much between them. They are very closely bunched up. So, and they are actually very close at the center. So this is both accurate and precise. Here, the darts are very close to each other. The difference between them is not much, but they are away from the center. So these values are precise but not accurate. These values are accurate. They are in the center, but they are very far from each other. So these values are accurate but not precise. This, they are not in the center and they are far away from each other. So these values are neither accurate nor precise. So this is the difference. Let's look at the types of errors. There are broadly two types of errors: systematic and random. In systematic errors, they are because of the instrumental error and imperfection. Instrumental error. Instrumental error is when an instrument consistently gives incorrect reading. Like, for example, there is a weighing scale, it consistently gives 500 grams more than the actual weight. Or let us take a thermometer where the markings are incorrect and the temperature is 1 degree less than the actual reading. So, systematic errors are predictable. We know that there is an error and we always know whether it is more or less than the actual value. So, by knowing that, we can correct the systematic errors. Random errors. Random errors are, as it says, random, unpredictable. We don't know whether it's going to be more or less. Like fluctuations in voltage, fluctuations in temperature, fluctuations in pressure. All these are unpredictable. We cannot predict. So the errors could be more than the actual value, true value, or less than the true value. So how do we correct the random errors? We take a large number of values and average them out. Let us see how we calculate errors. So first we need to find out what is the actual value or the true value. Since we do not know that, let us say we do an experiment and we measure the values A1, A2, A3, so on up to AN. Then we take the average of these and that is considered as the true value or the mean value. So the value, the mean or average value is A1 plus A2 plus A3 so on up to AN by N. So this is the mean value. The absolute error is the difference between each reading and the mean. So here in the first reading we have A1 minus A. See, notice this mod. This is called absolute. We always take the positive value. And the absolute error in the case of the second reading is mean absolute error is the average of all these readings. So we have, and this is denoted by delta A. Delta A. Delta A mean is, we have the mean of the absolute error. The mean absolute error is we take all the absolute errors of all the readings and then we average them out. Remember this mod sign. We are always taking the positive value of the difference. That means if it is 5 minus 3, mod is 2, and 3 minus 5 is minus 2, but we take a mod, it becomes positive. We take all the positive values only and we divide it by n, and that's our mean absolute error. So finally, what do we say? What is the reading we got? We say final value is plus or minus delta A bar. So this is our final result. So what do we do? We measure, we take a lot of measurements. Let us say we have taken n measurements, and then we find out the average of those measurements, and that's the A mean. And then we find out the absolute error, how much each reading has deviated from the mean value, and we take positive value of that. That is the absolute error, and we take the average of all these values, and that is called the mean absolute error. And then the final reading we say is the mean plus or minus this much. This is how we calculate errors. In the next class, we see what happens to these errors when we add values, multiply, divide, and subtract. All right.